so that we can refer that one and prepare the abstract sheets. Okay. Now we will be starting with the quantity of steel in RCC elements, the bar bending schedule. In short, we will be calling it as bar bending schedule. The reinforced cement concrete, which is usually estimated under two items. The concrete wall include centering, centering, and binding of steel bars in position is taken under one item. Under one item is mentioned in terms of cubic meter or cubic feet. Depends upon the what type of dimensions you are using. MKS system or IS system. Depends upon that, it will change. Next is the quantity of steel being small. No deduction is made for steel from the value of concrete. अगर तुम लोग concrete beam design कर रहे हो, तो the value of concrete will be not deducted by the steel, because steel will be of maximum of 1 to 4% only in the reinforced members. Therefore, there will be no deduction in the concrete. It will be a negligible value in the concrete members. Binding wire is not taken separately, but included in the item of RCC walls. Here, binding wire will be not considered as a separate item, like will be calculating. Item mean will be calculated separately as quantity of excavation, quantity of brickwork in footing or superstructure. This is the item numbers. Like that, the binding wire will be not considered separately, but in the steel calculation only will be adding the some percentage of binding wire for calculation of the binding wire quantity required. Next is centering, and centering may also be taken under separate item in square meter or square feet, because it will be then the thickness of the centering will be not considered, only the area will be considered, which will be mentioned in terms of square meter or square feet. Bending and binding of steel may also be taken as separately in terms of quintals. That will be counted in terms of the value, that will be in terms of quintals. Next is steel reinforcement is calculated as per actual requirement as laid in position, including overlapping, hooks, grinds, etc. Whatever dimensions are given for the bar bending or the steel in the reinforcement, as per dimension, actual length of steel bars will be calculated. If it is given with overlapping, that how much overlapping you are giving, that also you need to measure. If you are giving hooks at the end of the steel bars, you would have seen many steel constructions are the reinforcement alignment before laying the concrete. Even in the last year also, we have taken to our school building construction at the top floor, where the reinforcement was laid, the concreting was started. You saw how the reinforcement were laid. The binding wire was there, some of the venter bars were there, some of the crank bars were there, hooks were given at the ends. Those all components you need to measure and write the actual length of the steel bars and determine from the detailed drawing. Detailed drawing will be provided to the site engineers, and those has to the estimators, those has to calculate exact value of the steel. Here it comes, the quantity of steel. If the detailed drawing are not available, the steel reinforcement may be calculated approximately on the percentage basis of concrete. The density of steel may be taken as 78.5 quintals per cubic meter or 7.85 grams per cubic meter. Remove this one. This is not actually correct. It is of 78 8.5 quintals per cubic meter is the quantity per cubic meter. अगर तुम लोग 78.5 क्विंटल स्टील को एक 1 क्यूबिक मीटर कंटेनर में डालोगे तब तुम लोगों को कंप्लीट 1 क्यूबिक मीटर वॉल्यूम मिलेगा. The percentage of steel reinforced depends upon the design of the structure. As I said, the percentage how much you need to add to the reinforced windows, it will be based on the design, not an approximate value you have to consider. But in an average, if you are considering the approximate when the detailed drawing is not available with you, in such cases, these percentages will be considered. In absence of detailed design, the percentage of steel concrete may be taken approximately as given below. That is, lintel slab will be up to 1%, 1.7 to 1%. For beams, it will be 1 to 2%. For columns, it will be 1 to 5%. And for foundation, it will be less. That will be of 0.5 to 0.8%. This will be the percentage of steel requirement if the detailed drawing is not done or it is not available. How to find out the extra lengths and all will be dealing. For a small span, light load, less steel is required, and for bigger span, heavier load, greater amount of steel is required as per the design aspects, which is quite clear. In RCC work, the end arc side covers of steel bars may be taken as 40 mm to 50 mm, that is 1.5 inch to 2 inch, and the bottom and top covers may be taken as 12 mm to 20 mm. Sometimes it will be given as 25 mm also. That will be 0.5 inch to 0.75 inch. For slab, and for slab it will be of 25 mm to 50 mm. For beams, 12 mm to 40 mm it will be for slab, and 25 mm to 50 mm for beams. It will be given the covers, the mortar cover or the concrete cover for reinforcement will be given. The length of one hook may be taken as 9 times of dia, that is 9D or 9 dia of bars, and the total length of straight bar hook at both ends may be taken as L plus 18 dia, the diameter of bar, and which is given over here. You can see the diagram. Here, first one is of, if you want to calculate one end to another end, how much of length is required for steel. Suppose my building is of 5 meter span. I cannot write directly 5 meter because 5 meter will be of having the wooden covers. That may be 25 mm, that may be 40 mm, that may be 50 mm. Whichever it is given in the design, that you need to deduct, and you need to add hooks at the end to hold the reinforcement in line. The hooks will be provided at the ends, like U-shaped hooks will be provided, or L-shaped hooks will be provided. That will be depends upon the design again, whether it is required U-shape. Now, whatever diagram is visible to you, that is of U-shape, and both the side it is provided for a span of length L, and if you are providing U-shaped hook at the end, you need to provide at a height of 4D, 4 times of diameter, and for a span of extra bend will be of 4 times of diameter, and the bend curve will be considered completely as 9D. That is 4 vertical and 4 horizontal. And bend will be considered as 1D extra. Therefore, total it will be considered as 9D. If you are providing both the sides, it will be 9 into 2D because it is provided on both the sides. Therefore, length of straight bar can be calculated as horizontal length, that is clear length plus 18D. D is diameter of bar. Whatever. Now you can calculate for 5 meter of beam with the 5 meter of span, effective span, 5 meter, and both the set hooks are provided. Tell me what will be the actual length and total length of the bar. L value is 5 meter. Find out what will be the total length of the bar and post your answer. Okay. Only SSR is available from the PWD department. Now find out what will be the length of this one if L value is 5 meter and the diameter of bar is 10 mm. Diameter of bar is 10 mm. Find out what will be the total length. Simple calculation. Okay, that's a simple calculation. Next will be finding how the bent up bars will be provided. For 45, there will be usually of 3 variety of bars. Nowadays, it will be of maximum of 2 variety only. And if you go in advance, there is no bent up bars. Only for beams, in some cases it is used. Otherwise, in slabs, there is no bent up bars nowadays. It will be completely messes are providing from bottom layer as well as top layer for particular dimensions. Okay? But as for syllabus, you need to find out for bent up bars of 45 degree, 30 degree, and 60 degree. There are 3 variety of bent up bars, that is of 45 degree, 30 degrees, and 60 degree. Most commonly asked questions are for 45 degree as well as 30 degree. 60 degree questions were not asked till date. For 45 degree crank is nothing but bent up. That is from bottom layer to top layer it is going. Whatever this movement is there, from bottom layer to top layer movement of bar, that will be the crank. Are bent up bar, the additional length of one bent up is equal to difference in the length of hypotenuse and base, because here if you are considering this one, that will be considered as a right angle triangle. Hypotenuse and the base will be considered. The difference of both will be giving the extra length. That is this inclined length. If you are placing the bars in the horizontal direction, then length will reduce. If you are placing in the inclined direction from bottom layer to top layer, if you are going, the inclined layer, the steel length will automatically increase. Therefore, that length you need to find out. That will be done by considering the right angle triangle. If you are seeing this one, that can be done as by considering this right angle triangle. This will be of right angle triangle. This will be of 45 degree. This will be. What will be this length? Find out. That will be 1.42D. If you are considering this as 1 meter, base considering 1 meter or unit quantity, not even 1 meter, consider it as a unit. Dimension will see how much is there, that depends upon that, we can decide that. Considering 1, this will be considering as D, the height of the crank, that will be considering as small d, and you can write the inclined length, that will be, if you are writing tan equation, then you will be getting 1.42 D will be the extra length. And if you are removing the bottom, then it will be of 142 D. Because horizontal length, if you are considering directly, then it will be 0.42 D will be the extra length for crank bar or bent up bars. Note on these values. because we will be solving numericals on basis of this all components, U hooks, L hooks, uh, crank bars of 45 degree, 30 degree, and 60 degree, and stirrups, how to calculate stirrups. Those are all quantity calculation we are going to do. Therefore, note all these things. This can be done by considering this triangle. Here, the calculation is given. D divided by sin 40 minus D can be written as D into 1 divided by sin 45 is 0.0707 minus 1. D can be considered as 1. And then you can write the expression as 0.42 D. This is extra length. If you are considering baseline length plus 0.42 D, we are doing it for 45 degree, then you will be getting exact length of the stirrup or bender bars. If you are using two sides, then you need to write plus hook length. That is already the previous slide we have seen. That is 18D. Here, this D is, you can write capital D over here because you will not get confused. This D is the crank height and this D is diameter of bar. Okay? That will be the difference. This is done. Next, we will see how the 30 degree bend up will be considered. If it is a 30 degree bend up, for 30 degree crank, our bend up bar, inclined length of the crank is given as D divided by sin 30, that will be your 2D. Horizontal length of crank can be calculated as D divided by tan 30, that will be 1.73. That will be horizontal length. If you are considering again here the total length, if you are calculating, that will be calculated as L plus. If you are providing both the side cranks, it will be 2 into 0.73 D. Or else it will be, if it is one side, then it will be 1.73 D. That will be calculated for crank bar of 30 degrees. Here I can give the details of all as here. For complete length, if it is a U hook, L plus 18D. If it is crank bar of 45 degree, then you can write L plus 18D, both the side hooks, plus 0.42D. If it is one side crank, if it is two sides, then again here also you have to multiply 2 into 0.42 into D. Here capital D is used. Why? Because just to differentiate the depth and diameters. Similarly, it is given with the two sides. This is a one side crank bar, and this is two side crank bar. That will be L plus 18D plus 2 into 0.42D. And next, overlapping of bar. If there is overlapping of bar, then here, if it is overlap, then overlap usually it will be given with 40D and 45D. Between 40D to 45D, overlapping will be given wherever you need to change the bars. In such cases, overlapping will be given. With hooks are given, that will be multiplied with the 18D. Then overlap length adjoint can be given as 40 times D or 45 times D, whatever it will be given in the detailed schedule. That you need to write plus hooks. That will be added. If it is U-shaped stirrups are there. U-shaped stirrups are there. In such cases, the stirrup length will be considered as the hooks will be of 14D on one side. If you are considering on both the sides, it will be 28D. That will be given as L1 plus 2 times of L2, that is sides. L1 is horizontal length and L2 is vertical length. And 28 times of D will be for the hooks. Hooks for normal reinforcement it will differ, and for stirrups it will differ. For normal stirrups it will be 18D. If you are providing both the side hooks, if you are providing on only one side, it will be of 9D. Here in the stirrups it will be of 14D for one side, for two sides it will be 28D. If it is rectangular stirrup, previous one of U stirrup. Next is of rectangular stirrup, that will be of the 12D on one side hook it will be given. और if you are considering both the side hook, which means दोनों साइड से आके बेंड हो रहा है, that will be of 24 rupees. And total length can be calculated as 2 into horizontal side plus vertical side, because two sides you need to consider, plus 24 rupees. This one you need to take note of it, and while solving the numericals, these will be considered for finding out all the stirrups quantity, steel quantity in detail. Okay, this is required for finding out the actual value of reinforcement in the RCC members when you have the detailed drawing of reinforcement. Therefore, note down these values so that while note down and make it available when you will be solving the numericals. Either you write and post in your study table or write on the first page or last page of your notebook, so that easily you can, when you turn, you can identify. So this is for this. And preparing mentor bar, this form, this extra addition I need to do, or if you are using a straight bar, this addition you have to do. For this one, if it is a L hook, we'll be using 12D. Now all we are using U hooks, therefore I am writing hook length as 18D. If it is L hook, which means only the L shape hooks are provided. That will be horizontal bar plus 90-degree bend. That much is only there will be providing 12D, 6D on each side. Okay, this will be for the extra length calculations. This is for straight bar, bent up bar of one side, bent up bar of two sides, overlap bars, and stirrups of two different categories, that is of U shape and rectangular shape. That will be of these all extra lengths will be considered. You can see vectors for 30 degree is 0.27D. Yes.
सर वो वापस वो वाला सिरप दिखाओ ना, वो ऊपर वाला, वो दोनों साइड से दिख रहा है खुला हुआ, सेकंड लास्ट वाला सर.
This one.
सर नहीं, नीचे से सेकंड लास्ट. हाँ सर, इसके बारे में कुछ बताओ ना, ये इसको क्या बोलते हैं, ये वाले सिरप्स को क्या बोलते हैं सर, सेकंड लास्ट वाले को.
Serial number 6 and 7, the 6, 5 and 6.
Fifth one, 5.
This is of U stirrups, and this is of rectangular stirrups, where this will be the bars of rectangular. In some designs, this type of stirrups will be given, where this specific designs will be given. Whereas most commonly used stirrups are of completely rectangular stirrups to hold the all four members, all four stirrups in the rectangular position only. In the columns as well as in the beams, the stirrups most commonly used will be of the rectangular stirrups only. That will be completely blocked on all four sides. And this type of U hook or U stirrups will be used where the continuity of the bars are low. In such cases, this type of the special design will be done to hold the bars. It is not only for the rectangular beams or the columns. The rectangular beams and columns most commonly used stirrups will be the last stirrup. That will be used for common practice. And this will be used where the special design is there, where the continuous the steel bars are there, and you need to hold the different bars in different positions. Here we are using the rectangular portion only. In some cases, the one side may be more, one side may be less. Like that also, the condition may come, and that will be used in such cases also, where the L1 will be, L2 will be different. L2 on one side will be different, and on the other side will be different also, because of the design criteria. Rest will be depends upon the sale. You need to find out the quantities. Your details will be given in the detailed reinforcement drawing. From that only you need to find out the quantities. Now, the sixth will be most used stirrup, that is rectangular stirrup. The last one.
सर और सर्कुलर कॉलम में स्टीरप्स वाला जो रहेगा वो कंटिन्यू रहेगा कि उसके भी कटिंग करके लगाते हैं, वो उसका कुछ बताइए सर. सर्कुलर में भी होता होगा ना फिर?
Yes, circular stirrups will be there. For that circumference you need to calculate and then you need to add the extra length as 24D. Okay, this is the one type of stirrup, and as you said, the continuous stirrups will be also there. That will be continuously circulated, like cover up to the wheel bars. That stirrups will be also used in the circular columns. But it depends upon what type of design you are doing. It is not always fixed that you need to use this. Okay. The next stirrup, as I said, for 60 degree also, we'll be using stirrups, the bent up stirrups, bent up bars, or crank bars. For that, we need to add extra length as 0.58D. For 45 degree, it will be 0.42D, and for 30 degree, it will be 0.27D. Why 0.27? The calculation is shown in the previous this one. Here it is 1.73. It is of for tank inclination, and the base we are considering that will be 2D. 2D minus 0.27. 0.13D will be giving 0.27D. This will be the additional length for bent up bars or crank bars. Note on these three values, that is 0.27 for 30 degree, 0.42 for 45 degree, 0.58 for 60 degree stirrups. Schedule of bars. For schedule of bars is the list of reinforcement bars in a tabular form, giving the particulars of bars, shape of bar, the sketch of the bar, how it is visible, length of the bar of each dimension, each diameter of bar, then total length, total weight. Will be calculating schedule of bars. In tomorrow class, we will be preparing table for how to find out the steam quantity for particular given detailed drawing of the structure. That will be schedule of rates. Like in the previous classes, we used to refer for measurement sheet, where the serial number, particular length, breadth, height, and remark were there, quantity and remark were there. Here also one more table will be using, that will be having the diameter of bar, shape of the bar, the length of the bar, extra length to be added, the total length, weight for running of the steel bars, and then total weight of the particular bar and remark. Like that, we'll be using one more table for finding out the bar and schedules. That will be schedule of the bar. For each type of RCC work, the schedule of bar is usually prepared, depends upon type of work. We'll be preparing the schedules. Now we have to prepare schedule that will be taken in the upcoming classes. From the schedule of bars, the requirement of different size of the bars can be identified, length of the bar can be identified, and may be arranged and bent up during the time of construction. From drawing, we will be writing in the schedules, and we will be finding out what will be the quantity of steel bars are required, bent up bars are required, the hooks are required, stirrups are required. Those all will be given in the schedules. Depends upon the schedule, we can prepare the construction activity plannings. And then, what is the advantage of bar running schedule? Why you have to do it? There is a faster execution of work if you are already having the BBS at the site with the help of BBS, which reduces the construction cost and time. Second, BVS reduces the reinforcement wastage in cutting. If you are not having any plan, if you are not having the BVS, then randomly somebody will cut into as per the will and wish, and they will be wasting the steel bars. That will be wasted, that can be covered up in this one. BVS help in improving quality control at this size because the dimensions and wastage is reducing and the quality of steel what you are going to use can be monitored from the BVS. BVS is bargaining schedule. It helps in stock management, how much quantity you are having and how much you need to borrow. That will be managed from the bargaining schedule. Bargaining schedule will give how much quantity is required for particular quantity.